Good afternoon, children. So we are again here today to discuss about magnetic effects of current. Yesterday we talked about that when a charged particle enters a magnetic field in a direction perpendicular to it, then it follows a circular path. I also told you how to represent magnetic field on a piece of paper. Now we'll see that if it is not perpendicular, that is motion of a charged particle in a magnetic field when it enters at an angle. So motion of a charged particle when it enters the magnetic field making an angle theta with it. When the angle was 90 degree or perpendicular, it followed a circular path. This we did yesterday. Now, if you have understood that part, you will be able to understand this part easily. Now consider, say this is the magnetic field. A charged particle Q enters with velocity V, making an angle theta. Now we already know the path when the velocity component is perpendicular to the magnetic field. So what we are going to do is, now we are going to resolve this V into two components. Again, we have to know about resolution of vectors. Now what I'll do, I'll resolve this V into two components. One perpendicular to B and one along B. So this is the resolution. This is one component and this is another component. You can say it is the perpendicular component. Alright. Now according to the resolution of vectors, this component will be V sine theta and this component will be V cos theta. This is the parallel component. Now from the formula itself, F is equals to QVB sine theta. We had seen that for sine theta, theta equals to 90 degree, force is maximum. The value is maximum and the direction is, it will move in a circular manner. This we have done yesterday. So what will happen, because of this component V sine theta, which is perpendicular to B, this charged particle is going to move in a circular manner. So it will move like this in a definite radius. The necessary centripetal force being provided by the magnetic Lorentz force, which will be equal to QVB sine theta or QBV sine theta. Now what will this component do? V cos theta. This component is going to make it move in this manner and this component, that is the constant velocity V cos theta, the particle is going to move upward side by side. So this, it will move like this. See. The circular path because of this component, upward path because of this component, and the result is a helical path. Result is a helical path. The distance between two circular paths is known as pitch, and radius of the circular path can be obtained from this condition, that is mv square over r will be equal to qvb sine condition, that is V is equals to E upon B, can also be taken as velocity. Selector how see. We say F is equals to QE plus Q VB sine theta. For convenience, if we take this as 90 degree, then F will be equal to QE plus QV. Say if a charged particle is moving in both the fields, say E as well as B, but still the direction is not changed, then what does it mean? That is, the net force is 0. Net force 0 means it will be QE will be equal to QV B. So V will be equal to E upon B. So the particles which are having this much velocity, that is E by B, will only be selected and will go undeflected in electric as well as magnetic field. So this concept or this effect can also be used as for velocity selection. This is another point. Now this concept of motion of charged particle in a magnetic field can be used in a device cyclotron. And what is cyclotron? Cyclotron is a particle accelerator. See, this concept of motion of charged particle in electric and magnetic field is very important. You will get 1 or 2 questions in the board examination. Now, what actually cyclotron is? In cyclotron, the effect of circular motion due to magnetic field is being used for accelerating a particle. Now, the construction is such, we'll have 2 Ds, hollow semicircular Ds. Like you have a cream bottle or something like that, which is not of very much height, or like polish, in which you get polish, you just break it into half. So you get 2 semicircular Ds in this manner. This will be connected to an high frequency oscillator. Here the word oscillator is being used. You have not studied oscillators yet, but you know what are oscillations. And since it is a high frequency oscillator, means electric field will be changed at very high frequency using this oscillator. That means one time if this is positive, this will be negative. In the next it will be negative, positive, and this will be negative. Alternately it will become positive and negative depending upon the frequency. Very high frequency means very fast. Low frequency means slow. The particle is to be accelerated is kept at the center. This is known as D's. Say this is D1. This is D2. A small window is here, from where you can get the accelerated particles later on. And here we have got a deflecting plate for that, because we'll have to force the particle to come outside after it gets suitable acceleration. This whole assembly is kept between 2 magnets. Say you can have north and south. Or the magnetic field is so produced that it is perpendicular to the plane of the paper. We can have it in this manner. We can put dots. That means a magnetic field which is perpendicular to the plane of the paper, pointing in outward direction. The D's are also evacuated so that we don't have air or anything else. Otherwise, that will get ionized and will have extra ions. Now here, since we'll later on see that only the positive ions can be accelerated over here, being heavy, we cannot accelerate very light particles over here. So let us consider a positive ion is being accelerated. Let initially this D is positive and this is negative. So what will happen? Because of the perpendicular magnetic field, it will move in a circular manner, will be attracted towards the negative D. In the meantime, the polarity will change. It will get energy and will start moving in a circular path of varying radius, and after some time, due to the velocity selection or the deflecting plate, the accelerated particle will come out. Because of magnetic field, it is going to move in a circular manner. Because of high frequency rotate, is going to gain energy. Because it has to come to this side or this side alternately in the same time period. So speed will keep on changing. This is the concept of accelerating the particles in a cyclotron. And the necessary centripetal force is provided by the magnetic force. So from here we can find out V, we can find out R, we can find out also the energy of the emitted particles, accelerated particles. See, from here how will you find out R? We will cancel out with that. So R will be equal to B mv over BQ. You also know velocity is equal to distance upon time. For one circular path, distance covered will be 2 pi r, and for one path, time will be taken as time period t. So t can be also calculated as 2 pi r upon v. V you can substitute from this expression. 2 pi r upon v can be written as b q r upon m. R and R will cancel out. You will get 2 pi m over b q. This is T. As far as maximum energy of the particle is concerned, so kinetic energy maximum will be equal to half m v square. Substitute the value of v square from here or from here, this expression, and you will get the maximum kinetic energy also. Once you have found out the time period, you can also find out frequency. You can also find out angular frequency and simple frequency, both of them. So in this way, the cyclotron works. Go through this cyclotron and the velocity selection topic, and you can do a solved example given in your NCERT books based on cyclotron. So this much work for today. We complete this work and we'll come with a new topic tomorrow. Thank you.